Alright, morning honors algebra 2. Today we're going to start our next section. I apologize about skipping the activity. I just feel like that's going to fit better in for us once we actually get to that unit. So we will still get to do that activity, don't worry. We're just going to do it at the end of this unit rather at the beginning because it'll make more sense for it to be there. So today we're just going to jump straight into matrices, look at what they are, kind of how they are used, and really some immediate uses for them before we start to compare them to just our normal old number system. So if you notice with our notes, they're kind of set up towards today being the introduction. We're going to look at kind of what matrices are and how they get used. And then what you'll find a lot of our units do throughout the course of this year is that we try to show that other things besides just numbers can be added, can be subtracted, can be multiplied, and can be divided, as well as can be solved. Matrices are no exception. We'll do the same thing with polynomials later on. Same thing with rational functions, with exponential functions, and so on. So for today, being an introduction for us, we need to talk about two things first, one of which being the elements. The elements of a matrix are any number variable expression which appears in the first, or appears in any of the rows or columns of a matrix. These are basically the cells in a spreadsheet. So anytime you've used like Google Sheets or Excel, each of those individual cells would be a different element for a matrix. And then the order of a matrix, and this is an important one to remember. When we talk about the order of a matrix, it is a way to describe the size of a matrix. And it's listed as rows by columns. So as a quick example, if you were to have a matrix that maybe was something that looked like this, 1, 2, and 3, 4, 5, 6, 7, 8, 9, where there are a total of 3 rows, a total of 3 columns, then the order of this matrix we would say is a 3 by 3 matrix. Alright, so we got a couple more examples we're going to look at of the different kind of orders of matrices. The first being this matrix where it's just number 5, in which case there is 1 row, there is 1 column, so this is a 1 by 1 matrix. So for number 2, we have 1 row, we have 4 columns, so this would be a 1 by 4 matrix. And then for our last one here, we have a total of 3 rows, total of 2 columns, so it is a 3 by 2 matrix. Alright, so order is going to be very important for a few different reasons. It'll be very important as we put these into a graphing calculator later on today. It'll also be very important as we move into especially matrix addition, subtraction, multiplication, where the order determines whether or not you can actually perform the operation. So, next thing we're going to talk about is what's called the equality of matrices. And in order for two matrices to be equivalent, and matrices, anytime you say that, guys, is the plural of matrix. So you don't say matrices, say matrices. So when we talk about equality of matrices, first thing is they must have the exact same orders. That's already where order is going to be important. Have to be the exact same. And then the second thing is that the corresponding elements must be equal to each other. For example, just to give you a very basic example, if you had 1 and 2 equal to 1 and 2, you'll notice that when you look at these, they are the same order. They're both a 2 by 1 matrix because of 2 rows, 1 column. They also have corresponding elements equal to each other. What we mean by corresponding elements, the one up at the top here, 1 is equal to 1. We also have 2 equal to 2. Alright, so looking at some examples of this and how this works, it says solve for all variables in the following matrix equations. Well, in order for these to be equal to each other, have to have the same order, which they do. It also means that their corresponding elements must be equal to each other, meaning that x minus 4 must be equal to 0, and then you just solve for x, and x is equal to 4. It also means that all of these must be correspondingly equal to each other. So the 5 has to be equal to 3z minus 1. Solve that one real quick here. Looks like z is equal to 2. Oops. And then let's see, we've also got this 2y plus 1 is equal to 1. Go ahead and solve that one here. So 2y is equal to 0, and y is equal to 0. And then one last one here, it looks like 8 should be equal to 3w minus 7. Go ahead and solve there as well. And w is equal to 5. Alright, so there is kind of how you will solve for the individual elements of a matrix. I would recommend this. I'd recommend going ahead and trying one on your own. In a little bit, I'll work through part B, but if you pause the video right now, try one on your own, and then work through part B. I'll show you that one in just a little bit. Alright, so x plus 4, set that equal to 0 and solve. So x is equal to positive 4. Next one, 5 is equal to 3w minus 4. So 9 is equal to 3w. There should be a 5 here in case that was messing you up. And then 3 is equal to w. Let's see, next one, y plus 1 is equal to 5. That's a pretty easy one. So y is equal to 4. And then the last one here, 8 is equal to 2z minus 6. My personal preference when solving this one, if I can, I like to simplify as much as I can at first. So I would have divided everything by 2 first. 4 is equal to z minus 3. And then added my 3 over to say that z is equal to 7. If you solved it the traditional way and added by 6, you would have had 14 equals 2z, then divide by 2, and z is equal to 7. So it really doesn't matter how you solve, as long as you get the right answer. Next thing we're going to talk about. We're going to talk about what are called augmented matrices. What an augmented matrix is, it's a matrix of numbers in which each row represents the coefficients and constants for one equation, and each column represents a unique variable. So, and this is very, very simple. There's just a few things you have to watch out for. We're going to write each of the following systems of equations as an augmented matrix. So in order to do that, what I like to do is I like to go in and make sure that anywhere there would be a coefficient of 1, I write that in. And so then what you do in your augmented matrix is you basically write the same exact system of equations down, but you leave out the variables and you leave out the equal signs. Meaning the first row would look like this, 1, 1, negative 1, negative 2. And the second row would be 2, negative 1, 1, negative 5. And the third row would be 1, negative 2, 3, and then 4. Now, the things that you need to watch out for when you are doing this, and you'll notice this in this second example we're going to look at, is it's really easy to want to start going already and start saying that, okay, my first row is 5, negative 3, 9. My second row is negative 4, 8, negative 1, 4. And then all of a sudden this looks a lot different because there's nothing here, and then you put a 0. And unfortunately, that doesn't work. And so what you have to be kind of conscious of is if there is anything missing. So for example, in this first equation, how it does not have an x value, you need to either rewrite it or put a placeholder for x, meaning 0x plus 5y minus 3z is equal to 9, meaning that the 0, the placeholder, should have really been at the beginning of that line of the equation. Notice that also, guys, it's important to make sure that they go in order x and then y and then z. If they're ever out of order, then you run into some issues. And this w would have really messed things up. Let's go ahead and change this to be a y. And so that last row, negative 3, 2, 6, and then 13. All right. So augmented matrices, really not a whole lot to them. Again, just make sure that any placeholders you need, you put those in. Make sure coefficients, if they are ones, that you don't forget to write those. And then make sure that it's going in order of x, y, z, or whatever your variables may be. If it's not in order, then you need to put it into order. You need to put it into standard form. All right, so now let's talk about putting matrices into our graphing calculators. Let's talk about kind of how that works and how we can use that to solve them. So going through the steps, here are kind of your written out steps, and then I'll show you these steps on a graphing calculator as well. But step 1 is going to be where you enter the matrix into the calculator, and then you quit out of the matrix menu. Second thing to do when you're solving a matrix is you hit second x to the power of negative 1 and go to the matrix menu, and then move over to the math menu. Next, you will scroll down to option B, which will say RREF and a set of parentheses and press enter. What that stands for, RREF, stands for Reduced Row Echelon Form, which is something that we won't spend a ton of time talking about. It's a very special form of a matrix. You'll get to discuss it definitely a lot more in pre-calc next year. Number 4, go back to the matrix menu, choose whichever matrix you're going to use, close your parentheses and press enter. Step number 5, I want you to make sure that whatever you used as your augmented matrix and put into the calculator that you write out, and then write your solution as an ordered pair. Or oftentimes what we will have to do is, rather than it being an ordered pair, when there are 3 variables, it will be called an ordered triple. So just kind of keep that in mind. In fact, it says it down here, ordered triple. So when you have 3 different variables, just know that it's going to be 3 values instead of 2. So a triple instead of a pair. All right. So first thing let's do. Let's go ahead and make sure that this system of equations is written as an augmented matrix. So let's go ahead and go through that. 1, 2, 1, 1, negative 1, 2, negative 1, 1, 3, and then negative 2, negative 5, and 4. All right, so now putting that into the calculator, let's see how that works. So on your calculator, the matrix button, if you notice above this x to the negative 1 that's right here, it'll say the word matrix. So if you hit second x of minus 1, you'll get the matrix menu. Now yours will probably be blank. I have some of these in here that we're going to be using later. But what we're going to want to do first is edit. And so when we get into the edit menu, first thing we have to do is say what the order of the matrix is. So for this example that we're working, it looks like we have 3 rows and 4 columns, so it is a 3 by 4 matrix. And so once you do that, notice that it gives you kind of the matrix, has different boxes for each of the elements. This is where you're going to type in each of those values. Now notice when you press in a value, so for the first one I'm going to press 1, and press enter, notice that it moves you across a row. It doesn't move you down the columns. So as you go through those 1, 1, negative 1, negative 2, there's your first row. And then second row, 2, negative 1, 1, and negative 5. And then 1, negative 2, 3, and 4. Okay, so there's kind of step 1. Now notice that it's going to ask us to quit out of that, so I'm going to hit second mode for where that quit button is. Now, once we've done that, we want to go ahead and find the Reduced Row Echelon Form button, the RREF button. So go back to the matrix menu, go back over to Math, and probably the quickest way to get there, you can go and scroll down as far as you need to go, but it's so far towards the bottom, I usually just go up. And then here it is right here, option B. I'm going to select that Reduced Row Echelon Form. So there's step 3. Step 4, we're going to go back and choose which matrix we want to use. So go back into that matrix menu and look at all the names. Now notice that you should probably only have 1 there. I have, it looks like, a total of 6. And this is where it's important for me to make sure I keep all these straight. The ones that we just got done typing in was matrix A. Only thing we have left to do, close the parentheses, press enter, and now notice that it's going to be a matrix that looks a little different. We're going to write this down so you can kind of see what that all means. Notice that over on the left side it is mostly 1s and 0s, and we'll see why that's important later. Also notice that it's got some decimals, and anytime it's got decimals, I'm going to want fractions. I'm going to want them to be fractions unless they're irrational, in which case just round them to the nearest 10th. But for this one, to change it to fractions, go to Math, hit Answer as a fraction, and now keep in mind, usually we use this for numbers, it also works for matrices, to where it will take everything in your matrix and convert it to be fractions. So let's write that down as far as our matrices go. So what we did was we took this matrix that we had, and we have now transformed it to look like a matrix that shows us this. It shows us 1, 0, 0, 0, 1, 0, 0, 0, 1, and then negative 7 over 3, positive 22 over 3, and then positive 7. Now keep in mind, each of these columns was representing a different variable. This one represented x, this one represented y, this one represented z. So if you were to write this first row back as an equation, you would say that 1x plus 0y plus 0z is equal to negative 7/3. So in other words, the first row is your solution to the variable x. The second row, you'd say 0x plus 1y plus 0z is equal to 22/3. So there's your solution for y. And in the last row, you would say 0x plus 0y is equal to 1, and plus 1z is equal to 7. So there's your variable for z. And then just like when we were looking at systems of equations last unit, your solution needs to be written as an ordered pair or an ordered triple in this case. So negative 7/3, 22/3, 7, there would be your solution. All right, we've got a few more examples. I'm going to go a little bit more quickly through these. First thing I'm going to go through and do for each of these examples we're going to work is I want to write it in reduced or write it in augmented matrix form. So to do that real quick here, let's see, 2, 1, 1, 3, negative 1, 2, 2, 2, negative 6, 15, 5, and negative 26. Second one, 1, 3, 1, negative 1, 3, 3, 5, negative 1, 2, negative 6, 10, and 5. Third one here, looks like 1, 2, and be careful. Notice that for the x variables, they actually continue over here. So 1, 2, 3. Y's, same thing. So y is negative 1, 3, 2. Now z's, be careful. They only have a negative 1, a 1, put a placeholder of 0, and then 1, 2, 0. So the only matrix we really had to be very careful about was the last one, was D. All right, so putting each of these into calculator, I'll just kind of show you what those will look like. So in your matrix menu, over to edit, and then choose each of those matrices. I put them in different ones. You could just replace matrix A if you wanted to, but notice here's the matrix for example B. So a 3x4 matrix, notice that all the values are the same. So I'm going to go ahead and do my reduced row echelon form for that. I'm going to use one of those kind of tricks that we learned for calculator scavenger hunt. If you press second enter a couple times, it'll take you to back up into your history. And rather than doing a reduced row echelon form for A, I'm going to highlight A, back into my matrix menu, change that to be B, press enter, and here's my next solution set. So for this one, it looks like x was negative 2. It looks like y was a positive 3, and it looks like z was positive 5. Okay, so going to do the same thing again. I'm going to again show you my matrix menu, and again I'm going pretty fast, so if you need to pause the video to type all these values in, here's my next matrix. So here it is. Notice that they all match up. Okay, so I'm going to again go back into the home screen. I'm going to hit second enter to get up my last history. Change this to be matrix C. Press enter one more time. And here's going to be my next solution. So it looks like for this one, I'm going to have x is 1, y is 2, z is negative 1. So here that is 1, 2, negative 1. You can already see why matrices are kind of nice. Not only are these systems of equations, but these are systems of equations with 3 variables, which we never even got a chance to solve. And notice how quickly you're able to solve these using graphing calculator and using matrices. So one last time, and I've already got my numbers in there for D, so I'll just show you what that looks like. So changing this to be matrix D. Here is my next solution. Again, I got some decimals. If it's kind of nice numbers like that, I don't mind those sorts of decimals. I'm going to go ahead and change them to fractions though, just to be consistent. So it looks like my solution there, again I'm going pretty fast, so pause the video as needed, was a negative 3, a positive 9 halves, and then a negative 17 halves. Okay, so now I was already kind of talking about some of the applications of these. Let's look at a couple application problems and we'll call it a day. So the first application problem. This is actually the problem from one of our previous quizzes. Recently bought awards for an award ceremony at the end of the year. Trophies cost $12, medals cost $3. It tells you spent $60, so let's go ahead and write our equation for that. So 12x plus 3y is equal to 60. I'm going to let x be my number of trophies. I'll let Y be my number of medals. It also says you purchased a total of 11 awards. So it looks like we ended up buying 11 awards. So here's our second equation. It says write and solve a system of equations, which we just did, to determine the number of each that you bought. Now, obviously at this point, if you still want to solve it by hand, elimination is probably the way to go. You could probably do some substitution. You could graph them on Desmos if you wanted to. But let's go ahead and use our new tool of matrices to kind of see what we get there. So I'm going to write an augmented matrix first. Here that is. And then let's go ahead and put that in our calculator. Let's get it in reduced row echelon form, and we'll rock and roll through this problem. So especially for those of you going to mathletics, these are some types of problems that you will sometimes see. I'm sure you remember these from elementary school, and you're going to see how much quicker you can solve these. And so if you notice, in matrix E, I've got this one already set up for us, which again is just to save us some time. So if you want to pause the video and make sure you get that one in there, be sure you do that. Go ahead and pull up the last time I used reduced row echelon form, which it looks like was here. Go back into my matrix menu. Matrix menu. We're going to select matrix E for me, since I haven't been changing them. And then, voila, already have an answer. Kind of nice. So it looks like in total, we were going to, based on our augmented matrix, which was now in reduced row echelon form, looks like we bought a total of 3 trophies. Don't forget your label. And it looks like we bought a total of 8 medals. Alright. So one more application problem, and again, I would recommend doing this one on your own. This one does set up to be a system of equations with 3 variables and 3 equations, but try it on your own, see if you can get it figured out. And then for sure, play the rest of the video, and I'll be working through that with you. Alright, here we go. So you have 85 coins, and we've seen this type of problem before. Nickels, I'm going to make that X. Dimes, make that Y. Quarters, make that Z. With a combined value of $13.25, twice as many quarters as dimes. I'm going to go ahead and write that equation out. So twice as many quarters as dimes would mean if you double the number of dimes, you'd get the number of quarters. And then we'll kind of talk about how we'll have to write that in our system in just a moment. But let's go ahead and write our other equations. 85 total coins is probably the easiest. You just write that X plus Y plus Z is equal to 85. And then coefficients, nickels are worth 5 cents, so 0.05x. Dimes worth 10 cents, so 0.1y. Quarters, 25 cents, so 0.25z is equal to the $13.25. Now notice for this equation, you need to get variables to the same side and everything else to the other. Does not matter how you do that. I'm going to choose to just move z over and say that 2y minus z is equal to 0. And so when you put that in, 2y minus z is equal to 0. Notice that there is no x for that equation. If you want to go ahead and put that in so you don't forget your placeholder, you can. But there is your system of equations. Next thing I'm going to do, it says in part A, I want to write an augmented matrix to represent the situation. So do that 1.050, 1.12, 1.25, negative 1, and then 85, 13.25, and 0. So there's my augmented matrix. Last thing it's going to have us do, it says in part B, use a graphing calculator to find the number and type of each coin. Okay, so let's go back to our calculator. Let's go back to that matrix menu. We'll go to edit. I'm going to edit number 6, which is F, just to show you that here's all those values. And again, this is a good time too, if you need to pause the video to kind of get those in, please be sure and pause the video. Don't just rush through this. But then once you've done that, I'm going to quit out. I'm going to go ahead and pull up my last time I used RREF. I've been using it a lot, so that was pretty quick. And then I'm going to change my matrix name, since now my matrix that I'm using is matrix F. I'm going to change that here, press enter, and boom, there you go. So you can see matrices, very nice, very applicable, something that you can use very quickly to solve systems of equations. Let's go and write our solution down before we talk about what's coming up. So it looks like in total we had 25 nickels. So X was equal to 25. It looks like for Y we had a total of 20 dimes. And then for Z, we had a total of 40 quarters. Okay, so for Monday, notice that being Friday and not having gone over anything new, we not having a quiz today. So on Monday, we will be going over our next section, which is matrix addition, subtraction, and scalar multiplication. So we're going to start to see how matrices, just like numbers, can be added, can be subtracted, can be multiplied, and can kind of be divided. And when we get to division, that's where things get a little bit different. These notes, guys, are already going to be on Schoology for you. The homework assignment is still going to be through a Big Ideas assignment. Unfortunately, Big Ideas kind of quit working on my end, so it's being posted as a couple of pages of different problems, kind of like out of a textbook. So be sure on Schoology when you check for that. It's going to look different. It's not going to be in worksheet format, and it's not going to be actually on Big Ideas, but it is going to be one of their assignments, and I'm just picking out which problems I want you to work. Later on over the weekend, I will post an answer key so that you can check your work as you go. And then on Monday, we'll go over any questions that you've got and get kind of caught up from there. Otherwise, guys, I think that's all I've got for you. Be sure to get working on that homework and have a great rest of your Friday. I will see you on Monday, guys. Have a good one.